Okay, arc length is the measure around the outside of a circle. So this is related to circumference. But our arc length, our circumference is the whole circle. It's 2 pi r. But our arc length does not have to be the whole circle. It can be part of the circle. So what I need to know, if I have my circle and I want to know from here to here how far it is, what I need to know is, if I know the angle, it tells me what percent is a percent of the whole circle. So that's how we're going to work with arc length. We have the arc length, which we denote as S, and that's the part of the circle. We have the circumference, which we denote by C, and we know that's 2 pi r, and then we have the angle that it covers, and that's theta, and then we have the whole, and that's 2 pi radians. And you can do it in degrees, but we're going to be working in radians right now. Just remember that it's 360 degrees. Okay, and then your angle would have to be in degrees as well. So if your angle's in degrees, you could use 360, or you can convert it to radians. So what I have is I have S over 2 pi r equals my theta over 2 pi. And I can solve for S, so S is theta over 2 pi times 2 pi r. Those go away, so it turns out that my arc length S is just theta times r, as long as theta is in radians. Okay, it's always about the part for the whole. So let's look at an example. I have a radius of 6 feet and a theta of 2 radians. I want to find S. Well, S is just theta times r, so my arc length is 12. And it's 12 feet, because the radians were canceled out here. Now, what if I have a radius of 6 meters and an arc length of 8 meters, and I want to know my theta? Well, I know S, right, is theta times r, so I know 8 is theta times 6. So if I divide, that gives me theta is 4/3 radians. I have one